we're going to talk about source code management and the various repository models that are available to us as software engineers as we begin to develop our software and help us manage that chronology of change that happens to our software as we are developing. We're going to talk about the single repository model that was the traditional model that we've been using for decades. And then we're going to talk about the distributed repository model that came out early 2000s and which is now the preferred method for change management. And we're going to talk about primarily GIT, which is the utility, a really nice open source utility that's provided to us to do distributed repository models and manage all the change across our software. Get ready, we're doing it now. We're going to start off with the single repository model. Now in the single repository model, we're talking about a repository. So a repository is the location where we are going to store all of our source code, as well as all of the artifacts that maintain the chronology of change to that source that we're working with. So we call that a repository. Now in the single repository model, we have, as it implies, a single repository, and that repository is located somewhere. So let's dive into this diagram that I have here on the screen. Now, the repository itself, which we have right here, let me go ahead and let's turn on our drawing ability. Now, this core repository is, like I said, where we keep all of our source code, and we record the changes that happen to the source code over time. Now in the single repository model, that repository can be located either on a local server within the local network at a company or a business or your own house, or it can be located up in the cloud. So some cloud service provider might have a remote repository option for us, or we might have it at a co-location or in a data center that isn't on our local premises, but we can get to it via the internet or via a network. And that is where the repository lives. That's where it is. That's the location from which everybody accesses the source code. And the important part here is that because the repository is either on a local server or out on a cloud server or a cloud service, that code has to be transported down to a developer's machine. So when we have a team of developers, we've got multiple people, tens of people, or even hundreds of people working on that code base that's stored inside of the repository. So we need to get that code down, and that's usually done through what we call a checkout. So right here, we're usually checking out the code from a different location within the repository. So a lot of times inside of a repository, we have branches, and we'll get deep into what that means, but we usually have the core repository, and then we have a branch, which is where we take all of the source that is in the primary repository and we check it out into a branch with its own timestamps and its own history, and it is kind of its own version of what is in the repository. And so that branch, we're usually checking out from a branch in a single repository model. And so we usually check this out to the developer's local machine, and all of that code gets checked out into what we call a working directory. And the working directory is sitting on the developer's machine. So my computer right here, I would have a folder on my computer, and when I do the checkout from the repository, all of that code comes down into my computer, into that working directory. And it's in this working directory, which is just on my file system, that I go ahead and I edit that source code by using an IDE, so an integrated development environment, or through a text editor or another program like that. So I'm editing the source that is found inside this working directory, and then I'm testing that source locally using a development server. So a web server that's running on my current machine if I'm building a web application or some web software. Or it might be that I'm executing that software directly on my machine because I'm working on a Windows desktop application or a Mac OS desktop application, or maybe a utility or a command line utility or something like that. So I'm going to go ahead and edit the source code and test that source code on my machine as a developer, and that's all happening here inside of the working directory. Well, once I'm done editing the code, once I've tested it and I feel like it's at a point where it needs to go back up to the repository, either because somebody else needs to access it, or I've completed a feature and I need to get that feature back up into the repository to keep it safe just in case my machine crashes, Then I'm going to go ahead and commit that code back up to the branch that I checked it out of. And in this example, we're checking out of development, which makes sense because I'm a developer. I'm working on that source code. I'm developing a new feature or I'm fixing some bugs. And when I'm done with that task, I need to commit it back up to the same branch I pulled it from. So that's going to go right back up here through what we call a commit. And that's going to come up into the development branch. Now, once we've got a lot of check-ins and a lot of work that's done, maybe we have 5 or 6 developers, they've all been working on different tasks as assigned, they've completed those tasks, they've tested them, all the code has been kind of worked together, all those changes and all those features have been merged together, and everything works inside of development. Usually what's going to happen is that code is going to be pushed to another branch that we call staging right here. And in staging, all that code gets pushed to staging into that branch, and then it gets pulled down into a staging server. Now, this server could be anywhere. It could be on the local network, on a local server, or it could be up in the cloud. It doesn't really matter. I just kind of have it grouped here inside of this cloud service / local server where the repository is. It's probably on a machine of its own, but we have it here just to show how the transfer of code goes from one branch to the next branch within a repository. Now, because the development branch, the staging branch is a copy of whatever's in development at a certain point in time. So it's just a copy, it's another version of that source code with all the stuff that exists inside of development. Now, once all that code has been pulled from development into staging, this allows the developers to continue working inside of the development branch and continue to work on more features, fix more bugs, or do more stuff while your QA team is actually working on testing all the changes that were made previously. And this is why these repository models are super important, is because we can continue work while another group, so our QA department, is also doing work. And once QA has tested it and found it all working and nice, then they can push it to production. So if you remember, this goes back to the software development workflow that we discussed in another video, where we were going through that development process. And now you can see how that software development workflow correlates, or how it relates to the repository model, how we are keeping a chronology of change of the software over time as we go through that software development process, that non-linear software development process. Now, once it gets to production, once it passes QA, then we get it pushed to the production branch. We now have a version that usually gets added, like version 1.5, and then it gets pushed out to the production servers, and that becomes our live production code, or it gets compiled and is turned into an executable, and it becomes a new version of an application that somebody could download and install locally on their computer if it's a desktop app. Now, in this single repository model, we are dealing with just this one single repository right here, and everybody is checking in and checking out code from branches that live within this repository. Now, that's the single repository model, and we're dealing with just a core repository that is in one location from which everybody pulls and pushes their changes to branches that live inside that repository at that single location. Now, this was the primary way in which software developers tracked change or did change management for their software in the past. In the early 2000s, a new model was developed that supersedes this model and is the primary model used today, and it is the distributed repository model. Now, it is built off of the single repository model, but it has some advantages, but it becomes more complex. Of course, the more advantages you add to software, the more features, the more abilities, usually that software becomes more complex over time. So taking this single repository model and then moving to a distributed repository model, we end up with some differences here. So I'm going to go ahead and let's get out of that. I'm going to go ahead and move over here to the distributed model. Now you can see it gets just a little bit more complex, and we'll go through this one. And once we go through this distributed repository model, then we'll get into the differences between the two and what the benefits are and what the disadvantages are. So let's run through this really quick, the workflow in a distributed repository. Now in this model, let me turn on my drawing really quick. In this model, we still have a local server or a cloud service where our repository lives, just like in our single repository model. The difference here is that instead of just checking out information just from the development branch down here to a working directory, instead, in a distributed model, as the name implies, we're going to take that central repository, that primary record of all change that has happened to the source code that we're working with, and we are going to replicate the entire thing to the developer's machine. And we can see that happen right here through this clone command. And we can see that instead of just the development branch and the code being put into the working directory, instead on our developer's machine, we are actually pulling down the entire repository as a local repository on the developer's machine. Now, because we have cloned the entire repository down to the developer's machine, the developer now has a complete history and a complete copy of the repository. Now we have it in multiple places, and I bet you can start to think about the advantages that that provides to not just the software developer themselves, but to the entire team, as well as to the entire chronology of that software or the ability to manage change within that system. And we'll get into those in a minute, but start thinking about it. So with that local repository, we also get a copy of everything that's in there. And here, when we copied it down, we would still have a master, a staging, and a development branch down here, but we're focusing primarily on this development branch that got copied down with the entire repository. So it still has the master, it still has the staging down here in this local repository, but we're just not going to focus on it. We're going to focus on the fact that now that we have the entire repository, we can go ahead and we can pull directly from a copy of the development branch within the repository on our local machine, and we can go ahead and we can create our own branches for what we are doing on our own machine. Therefore, we're not editing the development branch directly. We're actually going to create a new branch, and maybe this is feature dash. I've got a star here. And so maybe we're creating a new feature in this new feature in the software. So maybe it's feature dash user profile. We're creating a user profile for our users. Now, we're going to check out the source code from this new branch, which is a copy of the development branch. We're going to copy that into our working directory. And then it is within this working directory, just like in the single repository model, it is in this working directory that we're going to go ahead and use our IDE or text editors to edit the source code. And then, of course, we're going to use a local development server in order to test that code from within that working directory, or we're going to execute that executable desktop software on our machine locally to make sure that all the changes we're making to it works. And then again, once we're done, that code will get committed back up into this branch, and we're just going to keep that cycle going like we did in the single repository model. Until finally, we feel like everything's working the way it's supposed to, everything is good. Then we will take what's inside the feature branch, merge it back into the development branch, and then we may kick off another feature. We might be working on another feature. Now this is where it gets a little bit more complex. I mean, that was additional complexity from the single repository model to the distributed repository model. But now, when we go to commit code up to the central repository, we get a little bit more complex because now we've got additional feature branches that don't exist in the central repository, and we've got changes that we've made to the development branch. So when we actually check stuff back in, before we check it in, we're usually going to have to go ahead and pull code or clone down the repository from any changes that our peers have made, other developers. And once we pull down anything that they have, we're going to go ahead and go through the process of checking for differences between what we added to development, what they added to development, and if they edited the same source files we did or changed anything, then we might have to deal with some conflicts. Now, once we've got all of their features integrated into our local repository, and we've decided whether or not we're going to keep these feature branches because we can delete them locally. And we'll get into all of this as we go through source management using Git. And this diagram right here shows you a lot using Git and the workflow using Git. So we'll get deep into this. If you're not quite following me right now, it's okay. This is a high-level overview of how a distributed repository works. And then we will actually go through the step of creating a repository, cloning a repository, and going through all these things that I'm overviewing right now. And then we go ahead, and once we're sure that there's no conflicts in anything that we've created, then we're going to go ahead and push all of this back up into our central repository. And then the central repository will have everything that's up to date. So this is the distributed repository, because the repository itself, the central repository, gets cloned to every single developer's machine. They have access to the entire chronology, all changes that have ever happened. Locally on their machine, they can actually go back through that chronology. If they need to go look at a source file and try to figure out what changed over time. For example, let's say that a developer went in, they made a bunch of changes, they created a feature, they did a bunch of stuff, and then they committed it up to the central repository. And then months later, they go back in because the feature isn't working anymore, and they want to figure out why it's not working. They actually don't need to go to the central repository to try to figure all that out. If they've got an updated current version of the repository, they can then begin their feature branch to fix the bug, or a bug branch. And then they can actually look through the chronology and pull down out of their repository different versions of the source files they're working with to try to see where a change happened when the feature stopped working. So they can actually pull down different versions of the software, test it, and actually find the point where the software stopped working, the bug was created. And then through that chronology, through that change management, they can also look to see who created the change, and then they can see any notes that that developer put in as to why they made the change. So that gives you context surrounding the change as well as the chronology as when it happened. This is really important because that allows this developer to then go talk to the developer that made the change and say, hey, what were you trying to fix? How were you trying to fix it? Why did you do this? What's the purpose behind it? That's if the notes weren't good enough, right? And so this change management is super important, and this distributed repository model actually creates a lot of advantages. So let's go over those here in a minute. So let's talk about the advantages and disadvantages of the single repository model and the distributed repository model. And let's try to understand why the distributed model is actually the preferred one nowadays, even though it is more complex, has more steps, and requires a little bit more effort. The advantages to that distributed repository model is actually quite significant, and that's the primary reason why we use it today. So let's start out with the single repository model. One of the biggest problems with the single repository model is that because we have a repository that is sitting in one location, either on a local server or a remote server, it is a single point of failure. Meaning that if that server goes down, or if the internet crashes, or if for some reason you can't get to that cloud service, you haven't paid for it, or that service goes down, or heaven forbid that entire service just goes out of business, you don't have that repository. That repository is gone. So what happens, since there's a single point of failure, you really have to make sure that you deal with redundancy, because there's no redundancy built into the single repository model. There's nothing to clone that entire repository to other locations in order to keep it safe or to keep yourself so that you have a version of it. So with that, the external backup process that has to be implemented by you, by the software development team, or by the company becomes critical. If you don't have a consistent, constant, and very timely backup, the possibility that you lose days or hours or even weeks of software developments of your entire software development team's effort is really high. And so, when you get a single repository model, you better have backups that are running like every hour, so that the max you lose in effort is 1 hour of developer's time, because you can go back and restore a backup. If for some reason your IT department isn't thinking about it, or your software architect or the product manager aren't thinking about this, and you just have weekly backups, you could end up where your entire repository dies or crashes at some point during the week, and you only have last Sunday night's backup or last Saturday night's backup, and you lose an entire week's worth of effort from a team of a couple of people to anywhere to hundreds of people. And that is a loss of time, effort, money, competitive advantage, business advantage. And that gets really scary. So with that single repository model, it became super important that we had a really good IT team that was doing a really good job backing things up and really fast at restoring backups, and that the backups for things like this were done as frequently as possible. And of course, just like with the entire repository not being accessible, there's also the possibility that it gets corrupted. A developer uploads something or does something to the repository, deletes the repository, deletes a branch. They could do anything that could corrupt that repository or a branch, or delete things that shouldn't have been deleted. And if you don't have a backup of that repository that is current, again, you're running into a serious problem. So having that external backup process is super important. Now, the benefits, of course, are that the single repository model is easy. It's very simple. You have one repository with branches. You choose which branch you're going to bring down to your working directory. You work in it. You pull down any changes that somebody else might have made to the branch that you've been working in, make sure there aren't any conflicts, and then you commit your changes back up to that branch. And then you kind of let the software developer or the deployment manager, the software architect or the deployment manager worry about merging stuff through the other branches like staging and production, and then pushing it out to servers and testing and QA and all that kind of stuff. And really all you have to do is worry about the fact that you're pulling down the right branch, you're editing the code, you're doing everything you're supposed to, you're merging down other people's code to check for conflicts, and then you're committing your code up to the primary repository. Super simple for the developer. They don't really have to do much. So it's that ease of use that made it super popular and still provided you with that chronology and that change management. Now, when it comes to the distributed repository model, things got a little bit more complex, but redundancy was built in. We had a complete copy of the entire repository on every single developer's machine and anywhere else where that repository may have been cloned down. So on a staging server or on a development server or on a production server, wherever that repository gets cloned, you have a complete copy of it. You have that entire chronology. Now, that doesn't negate the fact that you still better have a really good IT team, that you're going to want to have a backup strategy for your repository, and that you're going to want that to be frequent so that you don't lose any work. You still want to do that. But it's not quite as critical. It's not as damaging to the business if for some reason you can't get to that central repository, or it becomes corrupted, or a branch gets deleted. Instead of worrying about IT getting a backup, you could actually just get to every developer right there in the room and say, okay, who did the most recent checkout? And it could have been like seconds or minutes ago. You can grab that repository from that developer's machine and actually make it the central repository, and you're good. You've got a complete replica of that entire repository, all of that source code, as of that point in time. You don't even have to worry about IT going to backup tapes and trying to back stuff up. Of course, you'll probably want to do that, but it's not as critical. I think you get the point. Now, it adds a layer of the complexity. So the disadvantage is that you get that layer of complexity that we kind of went through, where you've got the entire repository, you pull the entire repository down, you still have to check out from the local repository to your working directory. You've got access to all the branches. A lot of times you're going to create your own feature branches on your local repository so that you're not working directly inside of development. And then you're just going to work those features, merge them back into development. And then when you feel good, you're going to pull everything down from the repository, make sure you have no conflicts, and then delete any of those feature branches that you don't want to go back up to the main repository because maybe they're no longer necessary. Maybe you're not keeping a history of your local branches that you're using to keep your development separate from everything. So then you've got to delete branches, merge everything back into development, and then merge everything from the central repository in, check for conflicts, and then you have to push everything back up to the central repository. A few more steps, a few more commands you need to know. But in all reality, the flexibility of being able to create your own branches locally on your machine, use those branches to do testing and do your development. And if you decide to just chuck everything that you did because it's just not working the way you want, or the feature gets canceled, or your task gets resolved, you can actually just delete those branches and you've never touched your development branch. So you have a clean, perfect copy of development, and you can just kick off and start the next task by creating a new branch. And this is all happening local on your machine. And then really you just have to worry about merging development with anything that other developers have changed, and then pushing that development branch and all of your changes merged with everybody else's back up to the central repository. So it gives you a lot of flexibility, a lot of security, a lot of redundancy, and it is overall just a better way of doing change management in the software development lifecycle or the software development process.